Welcome again to another TechZonk video here on the TechZonk channel. We're still working with Pi4J. Pi4J is the Java framework that allows you to connect Java to the Raspberry Pi to interface the GPIO pin array, for example. We are working on the code that we worked on in the last video. So I'll definitely refer back to that video. You'll want to take a look at that if you haven't seen it already. We are still working with the very simple circuit, which is a simple single LED connected to a breadboard, connected to the Raspberry Pi. I've got that on and running right here, as you can plainly see. So what we're going to do is actually see how much mileage we can get out of this single LED. I'm here on the Pi4J homepage, but what we're going to be doing is we're going to be looking at code, and we're going to be referring to the Java documentation of the actual Pi4J API itself. Because we're going to do some exploration, I'm going to show you that the Pi4J homepage is actually quite helpful. In fact, it was that homepage that helped me sort of put together the example that you saw in the previous video. A lot of really good documentation, really terrific examples. I think I even mentioned in the last video, I'm not someone who's comfortable with creating circuits, but the documentation really walks you through a lot of the basics to get you going. So we're going to certainly depend on that, and we'll be jumping back over to the IDE and looking at some code as well. So let's go ahead and get started. What we'll do is we'll make some changes to the code that we did in the last video, and we'll commit those up to GitHub, and then we'll use GitHub to deploy our code changes to the Raspberry Pi. So without further ado, let's go ahead and begin. Okay, the first thing I want to do is do a little bit of refactoring, because I'm going to include a handful of new functions on our controller to allow us to send some REST requests to the Raspberry Pi and perform different functions. And these functions are really going to be based on what we discover in the API. Now, I haven't actually looked at this for about a week, and it's been difficult because I wanted to kind of get a handle on what I was going to do in this video, but I thought it would be more interesting to just sort of do that exploration in real time with you as I record, and we can make these discoveries as a group. That way you'll see kind of what I'm going through to page through the documentation and get an understanding of what the functionality or available functionality is. So the first thing I want to do, just because I know that I'll be repeating some code, is I'm going to do a little bit of refactoring. Let's see, I want to first, let me show you what my aim is. I've got some code right here, which I'll highlight. These 4 lines. And we're going to do this, we're going to need to do this check pretty much every single time we attempt to access the single pin that we're using on our Raspberry Pi. And you can see that what I'm doing is I'm getting an instance of the controller, and I'm initializing pin 1. I'm setting its default state, I'm giving it a name. You only need to do this one time in a single session, and that's initialize the pin, rather. So I would have to do this check every single time. I'd have to check to see if my pin field is in fact null, and if it is, initialize it. I don't want to do that on every single instance of a function that we're going to do on this LED. So I'm gonna start my refactoring there, and we'll see if we can just avoid some code repetition. So on that note, let me go ahead and begin. I want to get an instance back of my GPIO Pin Digital Output, and I'll call this method getPin. It doesn't take any arguments, and I'm simply going to take what I've got up here and move it down here, and that's it. So once that's done, I can return the instance of my my static field here, which is pin. So take a look up here at line 10. I've got this static instance of a pin, which I have been initializing in this light method here. And what I'm going to do is I'm just going to sort of consolidate that into this method down here. It's going to check that static field, check to see if it's null. If it is null, it's going to initialize it. If it isn't null, if it's already been initialized, then this will be completely ignored, and I'll just simply return an instance of my pin, which is, like I mentioned, a static member of this class. So I'll take this out. That's going to massively simplify what I've got up here in the light method, so I can do that. So this way I don't have to worry about initializing it on every method call. I can just make use of this getPin method and sort of simplify things. In fact, I might not even keep this light. I think what I'm going to do is just call out some of these things differently. In fact, I'll go ahead and I'll keep that method, but I'll change the method name to toggle. And I'll change the endpoint also to toggle. So that's our first step in refactoring and exploring. We'll go to the documentation and we'll see what else we've got. So this is the documentation for the Gpi Pin Digital Output, and that's the class that represents the pin in our particular code. And these are the methods that exist on the GPIO Pin Digital Output. Now, there are additional methods that I have access to because the actual instance of a GPI Pin Digital Output inherits from its parent classes. The parent classes being the GPI Pin Digital and the GPIO Pin, which I've got highlighted right here. So if you look, I've got a handful of methods that I can get some details on here under the GPIO Pin, which I inherit from. Get name, for example, get pin, get properties, etc. I've got some GPI Pin Digital methods here, like get state. I can check. These are probably Booleans for is high and is low. These represent the actual states, so I can check to see if it's either high or low and get a true or false in return. But then I've also got the methods that are actually native to the class itself. So I've got multiple implementations of a method here called blink. I've got high and low, which I would imagine just takes the pin state and makes it high or low. And then you've got pulse, set state, and toggle. Toggle, of course, we became familiar with in the last video and we're using currently. So what I'll do is I'll just go ahead and start making use of some of these. The first one is blink. There are multiple implementations of blink. One of them accepts just a single argument. Some of them take multiple arguments. It looks like the ones that are going to be most interesting and probably the easiest to demonstrate, because I don't have any definitions on exactly what these arguments mean. When I click on blink and I look, I've got really just a restating of the actual method signature without any sort of notes or commentary on what these things mean. You can look and say, well, it's probable that, they're asking for a couple of long values. It's probable that the delay and the duration represent millisecond values, but I'm really only guessing. We can go ahead and experiment and get a feel for that. So we'll go ahead and we'll mess with blink. We'll probably look at pulse as well. Toggle we already know. Let's see if there's anything that we want to explore from the methods that it inherits from its superclasses. Let's check out is high and is low. That might be interesting. So I think we've got a couple of things that we can start with. The important thing to understand is the Java docs are here. They're available, they're public. You definitely, when you're exploring, you definitely want to have this documentation up on your screen and look at what you have available to you. So what we'll do is we'll go ahead and we'll start with is high and is low. So let's do a couple of things, actually. I'm going to create a couple of new methods. I'll call this, let's see, we'll call this on. And it's just going to return, actually, let me do this. We'll say, let's return a new date. And I will make sure I've got that imported. We'll make it a Java util date. And we'll make sure that we output it to a string. So that way I just have an idea. I'll see like a different timestamp on each of these methods so that I know that I'm actually getting a new refresh response every time I hit these things. So here's what I'm going to do. I'm going to go ahead and I'm going to get pin. And I'm going to say that when we call the on method, I'm going to set the pin state to high. And we'll just give this an endpoint so that we can make sure that we can access it. I'll make use of my string annotation of request mapping, and we will just call this endpoint on. So you can get that with /on. And then obviously, if it's not totally obvious what I'm doing here, I'm making an on and an off so that we can manually turn these things on. We can control that. We'll call it off. Now I'm going to do some real-time refactoring because I think I have an idea of what I want to see here instead. I don't want to return this date string after all. I want to do something different. What I'm going to do is I'm going to say, I don't know. Let's go back to the documentation, because I think what I want to do is when I turn on the light, I want to return the pin state. So let's look at that. When we do get state, what does get state give us? So I'm clicking on the get state method, and it returns a pin state. So a pin state is a class. Let's have a look. Okay, here's what we can do. Let's go back. Okay, I'm looking now again at the GPIO Pin Digital Output. What I'm going to do is I'm going to say we'll get pin, and we'll say is high. That's Boolean. If the pin state is high, we'll say light is on. Actually, I'm going to do some more real-time refactoring. Otherwise, we'll say light is off. That's what we're going to do. So that I'm actually going to move elsewhere. I'm going to create a new method up here. I'm going to call this private string check state. And I'm simply going to return that string. So let me take this whole line. I'll copy that, and I'll move this whole line up here. Got two returns. I don't want that. I'll fix that. And that's what I've got. So what I'll do is whenever I change my state, I'll just have it return check state. So theoretically here, when I turn on my light, it should turn the light on and then inform my browser that the light is on. When I turn my light off, it should get the pin, change the state to low, and then it should inform my browser that the light is now off. So I'll put check state down here as well. So the other thing I want to check out are some of the methods that are actually on this class. So we've got blink. We've just exercised high and low, but we've got blink and we've got pulse. Let's take a look at those. Back to the code, I'm going to go ahead and I'm going to say string blink. Okay, I'm going to get a handle on my pin, and then I'm going to say blink. So there are multiple implementations here as the IDE is informing us, and we of course already saw that in the documentation. I'm going to make use of the two longs. So if we jump back over the documentation, I'm going to say, let's go ahead and indicate that the delay, and that's probably the delay between blinks, we'll make that 200 milliseconds. And as far as the duration is concerned, we'll make that last for 2 seconds. So that's going to be 2000 milliseconds. Let's try that. So I'll go ahead and I'll complete this by saying our first argument is a long of 200 milliseconds. And we want the duration to be 2000 milliseconds. And of course, I am just guessing that these are millisecond values as far as delay and duration. I'm not 100% sure, and the documentation didn't actually specify that, or perhaps I missed it. So we are just guessing here. So what I'll do is I'll return to the browser a string that just indicates that the light is blinking. So I'll go ahead and give that an endpoint as well. And what we'll do is we'll call that blink. And then we'll do one more. Let's go back over here. We've got pulse. Pulse, there's a handful of implementations. I'm going to keep it simple. I'm going to say, let's go ahead and pulse for a specific duration. There's no argument for delay, because it sounds like pulse is going to be a set delay as far as how quickly the pin state is changed. And of course, with an LED, if you're changing the pin state rapidly, that's going to make your LDE pulse as well. So we'll make this very simple. We'll exercise pulse with just this first implementation here. So we'll go back to our code, and I'll create a method, and that method is going to be called pulse. It's going to return a string. And again, I'll get my pin, and I will pulse fix that. We'll do pulse. And we'll say, let's just go ahead and pulse for 5 seconds. And then I'll just inform my browser. Light is pulsing. And that's that. The last thing, of course, I want to do is make sure I've got my annotation. We want to identify this as an endpoint. And quite obviously, we'll just call it /pulse. So, you can look over my code really quick. We've got a couple of new methods. We've got the check state, which is going to just give us a bit of a shortcut to inform us on whether or not the light is on or if the light is off, and we'll leverage that check state method in these two methods here. We've got on, which makes the pin state high, which should turn the LED on, and then inform the browser that it's on. And then we've got off, which takes the pin, changes the pin state to low, and then returns a string to the browser that indicates that the light is now turned off. Lastly, we've got blink and pulse. Blink, of course, just blinks the light. We're guessing that we're working with milliseconds here. So we're going to say for a time period of, and I'm going to change this to 5 seconds. We're going to say for a delay of 200 milliseconds, meaning blink, it's going to turn on and off for a period of 200 milliseconds. Go ahead and perform that activity for a period of 5 seconds or 5,000 milliseconds. Again, I'm guessing on the milliseconds. It's going to then inform the browser that the light is blinking. Then lastly, pulse. Pulse for 5 seconds, basically, is what we're going to be doing. So on that note, we'll go ahead and test out what we've got and see if it's working. I have created a new repository so I can share this code with you. All I need to do is just get this code up to GitHub, and then we'll deploy to the Raspberry Pi, and we'll give it a shot. We'll go ahead and we'll do that now. Okay, what I'm actually doing right now is I've logged into my Raspberry Pi through the secure shell, so I'm actually at the command line of the Raspberry Pi, and because I've got some code differences here, in fact I have a completely new project, I'm doing a Maven build, running Maven package. I want to go ahead and compile my project, and I want to make sure that it is compiled into a jar. And if you want to get the details on how that's accomplished, you definitely want to check out that last video. And now what I'll do to get it started is now that I've compiled it using Maven package, I'm going to go ahead and I'm going to fire up that jar, and that jar is in my target directory of the project, and it's named similarly to the actual project itself, with all the Maven snapshot and versioning added to it, with the .jar extension, of course. So that's what I'll do to go ahead and start this thing up. It'll take a couple of seconds, and then we'll see if our code is working. Okay, so I forgot one of the lessons that I actually had put out in the last video, which is that I need to be running this as root. If I'm going to access the GPIO pin array on the Raspberry Pi, I need to be running as root. It's a real bummer. It's a real unfortunate circumstance of working on this stuff. So let me just make sure that I call that out and that you see it. When you start up this application, you need to make sure that you start it up as root. So that's what I'm going to do, and it should prompt me for a password maybe? No, I think I've already entered that. But it may prompt you for a password. It's going to ask you for a root password if that's the case. So you need to make sure that you start the application up as sudo, and then that's going to ensure that it's running as root. And then, of course, the application will start up the way that you expect, and then you'll be good to go. So we'll let that happen, and we'll try this again. Okay, and now with that correction to our startup process, I've gone ahead and started up the application, and I can see in the startup and initialization process that a lot of the new methods that we have created have been appropriately mapped as endpoints, which is a good thing. I feel really good about that, in fact. So what we'll do is we'll jump back over to the browser, and I will go ahead and call up my Raspberry Pi using my internal IP address. My Raspberry Pi has this internal IP address because it's connected to my home network. My home network has assigned this IP address to my Raspberry Pi. That's how I'm getting to it. I'm running on port 9898. And what we're going to do just to make sure that we're up and running is I'm going to call that root endpoint, which should respond with hello world if we're up and running. So that'll take a bit to initialize, but it does come back, in fact, with hello world, which is a good thing. So what we'll do is we'll take a look at the Raspberry Pi using fancy editing techniques. In fact, we'll superimpose a real-time image of our Raspberry Pi right here on my screen. Look at that. Come on. That's pretty fancy stuff. And we will call that new method called, is it toggle? I think it's called toggle. It used to be called light. We changed it to toggle. And we'll hit that. It'll initialize the pin for the first time. It does turn it on, which is good. And when I hit that again, it turns it off, which is perfect. So let's run back to our IDE and we'll check some of the other things that we've done. So we've got this on and off endpoint, and on will turn on the pin, and it'll inform us at the browser level that the thing is turned on. Let's have a look and see if that works. So we'll call on and hit enter. It says light is on. Of course, the light is on. It stays on. Now we'll use off. That should turn off the light and inform the browser. It says light is off on the browser, and the light turns off on the Raspberry Pi. Let's go and see what else we've got. We have blink. We think that blink is working with milliseconds here in its argument. So we're looking for a 200 millisecond blink that lasts for 5 seconds. It should tell us that the light is blinking. So let's go ahead and have a look at that with blink. It says that the light is blinking, and the light certainly does appear to be blinking. And it looks like it stopped after 5 seconds. So I think we were pretty good there with our guess on the milliseconds thing. Let's try pulse. Well, maybe that's a pulse. It was pretty quick. If it was, it looked like it was just on. And it could be that if we go back to our documentation, we can change. Yeah, I mean, it looks like there are so many implementations of pulse that there's probably something that we can do to make it look a little bit more like a pulse. You know, when I'm looking at it, it looks like the light is just on. But there you have it. I mean, basically, you've got a handful of different methods that you can implement or rather invoke on that particular class that represents our representation of a pin. And then it's not just for LEDs. If you've got other hardware that's connected to these pins, turning the pin state on, or I'm sorry, high and low, is ultimately what activates the pin. So this is a very simple, straightforward example, but it could certainly get a lot more sophisticated. So what we'll do is we'll close this video today. We'll end it with a nice little blink. And I thank you guys for watching. Please, if you like this video, please be sure to like and subscribe. I've got plenty more to come. And hopefully we'll see you all again in the future. Thanks for watching. I'll see you guys all in the next video.